Introduction. Data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured, semi-structured, and unstructured data. After completing this chapter, the students will be able to describe what data science is and the role of data scientists, differentiate data and information, describe data processing life cycle, understand different data types from diverse perspectives, describe data value chain in emerging era of big data, understand the basics of big data, describe the purpose of the Hadoop ecosystem components. 2. 1. What are data and information? Data is a representation of facts, concepts, or instructions in a formalized manner, which should be suitable for communication, interpretation, or processing by human or electronic machines. It can be described as unprocessed facts and figures. It is represented with the help of characters such as alphabets, AZ, AZ, digits, 0 to 9, or special characters, plus, dash, forward slash, asterisk, comma, equals, etc. Information is the processed data on which decisions and actions are based. It is data that has been processed into a form that is meaningful to the recipient. Furthermore, information is interpreted data, created from organized, structured, and processed data in a particular context. 2. Data processing cycle. Data processing is the restructuring or reordering of data by people or machines to increase their usefulness and add values for a particular purpose. Data processing consists of basic steps: input, processing, output. These 3 steps constitute the data processing cycle. Data processing cycle. Input, processing, output. Input minus in this step, the input data is prepared in some convenient form for processing. The form will depend on the processing machine. For example, when computers are used, the input data can be recorded on any one of the several types of storage medium, such as hard disk, CD, flash disk, and so on. Processing minus in this step, the input data is changed to produce data in a more useful form. For example, interest can be calculated on deposit to a bank. A summary of sales for the month can be calculated from the sales orders. Output minus at this stage, the result of the processed data is collected. The particular form of the output data depends on the use of the data. For example, output data may be payroll for employees. Data types and their representation. Data types can be described from diverse perspectives. In computer science and computer programming, for instance, a data type is simply an attribute of data that tells the compiler or interpreter how the programmer intends to use the data. Data types from computer programming perspective. Common data types in computer programming language include integers. Int is used to store whole numbers, mathematically known as integers. Booleans. Bool is used to represent restricted to one of 2 values, true or false. Characters. Char is used to store a single character. Floating point numbers. Float is used to store real numbers. Alphanumeric strings. String used to store a combination of characters and numbers. Data types from data analytics perspective. From a data analytics point of view, it is important to understand that there are three common types of data types or structures. Structured, semi-structured, unstructured data types. 1. Structured data. Structured data is data that adheres to a predefined data model and is therefore straightforward to analyze. Structured data conforms to a tabular format with a relationship between the different rows and columns. Common examples of structured data are Excel files or SQL databases. Each of these has structured rows and columns that can be sorted. 2. Semi-structured data. Semi-structured data is a form of structured data that does not conform with the formal structure of data models associated with relational databases or other forms of data tables, but nonetheless contains tags or other markers to separate semantic elements and enforce hierarchies of records and fields within the data. Therefore, it is also known as a self-describing structure. Examples of semi-structured data include JSON and XML are forms of semi-structured data. 3. Unstructured data. Unstructured data is information that either does not have a predefined data model or is not organized in a predefined manner. Unstructured information is typically text-heavy, but may contain data such as dates, numbers, and facts as well. This results in irregularities and ambiguities that make it difficult to understand using traditional programs as compared to data stored in structured databases. Common examples of unstructured data include audio, video files, or NoSQL databases. 4. Metadata, data about data. Metadata is a data type, not a separate data structure, but it is one of the most important elements for big data analysis and big data solutions. Metadata is data about data. It provides additional information about a specific set of data. In a set of photographs, for example, metadata could describe when and where the photos were taken. The metadata then provides fields for dates and locations which, by themselves, can be considered structured data. Data value chain. Data value chain is introduced to describe the information flow within a big data system as a series of steps needed to generate value and useful insights from data. The big data value chain identifies the following key high-level activities. Data acquisition, data analysis, data curation, data storage, data usage. 1. Data acquisition. Data acquisition is the process of gathering, filtering, and cleaning data before it is put in a data warehouse or any other storage. Data acquisition is one of the major big data challenges in terms of infrastructure requirements. The infrastructure required to support the acquisition of big data must deliver low, predictable latency in both capturing data and in executing queries. Be able to handle very high transaction volumes, often in a distributed environment. Support flexible and dynamic data structures. 2. Data analysis. Data analysis is concerned with making the raw data acquired to use in decision-making, as well as domain-specific usage. Data analysis involves exploring, transforming, and modeling data with the goal of highlighting relevant data, synthesizing, and extracting useful hidden information with high potential from a business point of view. Related areas include data mining, business intelligence, and machine learning. 3. Data curation. Data curation is the act of a management of data over its life cycle to ensure it meets the necessary data quality requirements for its effective usage. Data curation processes can be categorized into different activities such as content creation, selection, classification, transformation, validation, preservation. Data curators, also known as scientific curators or data annotators, hold the responsibility of ensuring that data are trustworthy, discoverable, accessible, reusable, and fit their purpose. 4. Data storage. Data storage is the persistency and management of data in a scalable way that satisfies the needs of applications that require fast access to the data. Relational Database Management Systems, RDBMS, have been the main and almost unique a solution to the storage paradigm for nearly 40 years. However, the acid, atomicity, consistency, isolation, and durability properties that guarantee database transactions lack flexibility with regard to schema changes and the performance and fault tolerance when data volumes and complexity grow, making them unsuitable for big data scenarios. NoSQL technology has been designed with scalability goal in mind and present a wide range of solutions based on alternative data models. 5. Data usage. Data usage covers the data-driven business activities that need access to data, its analysis, and the tools needed to integrate the data analysis within the business activity. Data usage in business decision-making can enhance competitiveness through the reduction of costs, increased added value, or any other parameter that can be measured against existing performance criteria. Basic concepts of big data. Big data is a blanket term for the non-traditional strategies and technologies needed to gather, organize, process, and gather insights from large datasets. While the problem of working with data that exceeds the computing power or storage of a single computer is not new, the pervasiveness, scale, and value of this type of computing have greatly expanded in recent years. What is big data? Big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. In this context, a large dataset means a dataset too large to process or store with traditional tooling or on a single computer. This means that the common scale of big datasets is constantly shifting and may vary significantly from organization to organization. Big data is characterized by 4V and more, volume, large amounts of data zettabytes/massive. Datasets. Velocity, data is live streaming or in motion. Variety, data comes in many different forms from diverse sources. Veracity, can we trust the data? How accurate is it? Etc. Clustered computing and Hadoop ecosystem. Clustered computing. Because of the quantities of big data, individual computers are often inadequate for handling the data at most stages. To better address the high storage and computational needs of big data, computer clusters are a better fit. Big data clustering software combines the resources of many smaller machines, seeking to provide a number of benefits. 1. Resource pooling. Combining the available resources such as storage space to hold data, CPU, memory. Processing large datasets requires large amounts of all three of the resources. 2. High availability. And availability guarantees to prevent hardware or software failures from affecting access to data and processing. 3. Easy scalability. Clusters make it easy to scale horizontally by adding additional machines to the group. This means the system can react to changes in resource requirements without expanding the physical resources on a machine. Using clusters requires a solution for managing cluster membership, coordinating resource sharing, and scheduling actual work on individual nodes. Cluster membership and resource allocation is handled by software like Hadoop's YARN, yet another resource negotiator. Hadoop and its ecosystem. Hadoop is an open-source framework intended to make interaction with big data easier. Hadoop is a framework that allows for the distributed processing of large datasets across clusters of computers using simple programming models. It is inspired by a technical document published by Google. The 4 key characteristics of Hadoop are: economical. Its systems are highly economical as ordinary computers can be used for data processing. Reliable. It is reliable as it stores copies of the data on different machines and is resistant to hardware failure. Scalable. It is easily scalable both horizontally and vertically. A few extra nodes help in scaling up the framework. Flexible. It is flexible and you can store as much structured and unstructured data as you need to and decide to use them later. Hadoop has an ecosystem that has evolved from its 4 core components. Data management, access, processing, storage. Hadoop is continuously growing to meet the needs of big data. It comprises the following components and many others. HDFS, Hadoop Distributed File System. YARN, yet another resource negotiator. MapReduce, programming-based data processing. Spark, in-memory data processing. Pig, Hive, query-based processing of data services. HBase, NoSQL database. Mahout, Spark MLlib, machine learning algorithm libraries. Solr, Lucene, searching and indexing Zookeeper, managing cluster Oozie, job scheduling. Fig. Hadoop ecosystem. Big data life cycle with Hadoop. 1. Ingesting data into the system. The first stage of big data processing is ingest. The data is ingested or transferred to Hadoop from various sources, such as relational databases systems, or local files. Scope transfers data from RDBMS to HDFS, whereas Flume transfers event data. 2. Processing the data and storage. The second stage is processing. In this stage, the data is stored and processed. The data is stored in the Distributed File System, HDFS, and the NoSQL Distributed Data, HBase. Spark and MapReduce perform data processing. Three. Computing and analyzing data. The third stage is to analyze. Here, the data is analyzed by processing frameworks such as Pig, Hive, and Impala. Pig converts the data using a map and reduce, and then analyzes it. Hive is also based on the map and reduce programming, and is most suitable for structured data. 4. Visualizing the results. The fourth stage is access, which is performed by tools such as Hue and Cloudera Search. In this stage, the analyzed data can be accessed by users.